Hello, today I'm talking to Elliott Reid, who is a PhD student with the IPPP. And Elliott, can you tell me what the main focus or the main question your research is trying to answer, please?
Hi. So my research focuses on neutrino physics and dark matter physics. Usually when we design experiments, we design them to look for one particular piece of new physics, one particular thing. What I'm focusing on is looking at whether we can use experiments which we've built to look for dark matter to also learn something about neutrino physics so that we get the most out of the experiments that we have.
What's the difference between dark matter and neutrinos?
Neutrinos are a particle which exists in the standard model of particle physics. So that's our best current model of all the particles and the interactions which we think we understand. So neutrinos, they were first detected back in the 1950s, and we now understand them pretty well, although there are still some big questions around their exact properties. Dark matter is something else entirely. So dark matter was first postulated or hypothesized back in the 1920s and 30s. And at that point, astronomers were starting to look more closely at the movement of galaxies and large structures in the universe. And astronomers understand gravity. And so by looking at the motion of these objects, they can work out how much mass and therefore how much gravity there is in a system. But they also know how much a star weighs. And so they can also work out the mass in the galaxy by just looking at how many stars there are and working out from that and the number of planets and things how much mass there should be. And the problem they faced was that the two numbers they got didn't match. In fact, it seemed like there was about 5 times as much matter, according to the gravitational motion of the system, as could be accounted for by our understanding of stars and planets. And as our understanding of particle physics has improved, we've become more and more certain that none of the particles in our standard model, none of the particles we've ever seen or detected, can possibly account for that extra 80% of matter in the universe, which is what we call dark matter.
As a PhD student, how do you typically spend your time?
One of the nice things about a PhD is that the work is very varied. So some days I will be writing a paper, or at the moment I'm writing a lot of my thesis most days. But other days I could be reading other papers other people have published, trying to learn a little bit more about the projects that we want to work on. And other days I'll spend coding, writing programs to simulate physics interactions and experiments. And some days I'll be out of the office completely doing outreach, for example.
You've mentioned outreach at the end there. What does doing outreach involve?
Outreach is the term we use to describe all the activities we do to try and share our research with members of the public. So that might be going into a school to teach a class about particle physics, or it might be going to a science festival. For example, down in London, or we also went up to Orkney to an international science festival there. And we took exhibits with us in order to help us explain to the public what our research is and how a particle physics experiment works. It's something which I really enjoy doing. I think it's always fun to talk about physics with people, and people are generally quite interested in it. And it's also really, really good for the field in general, because first of all, it hopefully persuades people that what we're doing is important work. And also it can help inspire the next generation of particle physicists.
Outreach is definitely very important. But what do you do outside of the office when you're not working? How do you spend your time?
I have a lot of hobbies. During the pandemic, I've got quite into music production. My housemate and I are in a band. And I also like learning Spanish. I take evening classes at the university, and I listen to a lot of Spanish music, and I'm reading a novel in Spanish at the moment.
What inspired you to learn Spanish?
I wanted to learn for quite a few years, but it was actually while I was at a conference, a physics conference a few years ago in Spain, that I met a person who is now my girlfriend, who's Spanish and whose family don't speak English. So so that's kind of what has prompted me to really give it a good go.
Given your research topic, I think it might be quite an easy guess for this one, but which discovery would you be most excited to see in your lifetime?
That is easy. Yeah, dark matter. I would like to know what dark matter is.
Do you have a favorite theory for dark matter?
I've gotta be careful. I don't want to offend anyone. People all have their own pet theories. I really don't know. I think that it's quite an exciting time to be studying dark matter, in part because there isn't really one theory which is winning at the moment, and it means that people are having to be really creative and come up with all sorts of interesting possibilities for us to study. I like axions. Axions are fun.
And to finish, what is your favorite physics fact?
So, in order to work properly, dark matter detectors have to be really well shielded against any kind of radiation which could get inside and spoil our results. So you may know that if you want to shield against radiation, one of the materials you can use is lead. So often dark matter detectors will be shielded with thick layers of lead. But it turns out that everyday ordinary lead contains trace amounts of radioactive impurities, and even those can be enough to spoil our results. So we need to find a source of lead in which all of those radioactive elements have had time to decay away to nothing. And the place that they go to look for this really, really pure lead turns out to be ancient Roman shipwrecks. So the Romans used a lot of lead and they shipped it around the Mediterranean, and some of it sank to the bottom of the sea floor. And over 2,000 years, all the radioactive impurities completely disappeared, leaving this really, really pure lead. So particle physicists sometimes collaborate with archaeology departments. So they locate the shipwrecks, they bring the lead up to the surface, and then archaeologists get to keep the interesting bits, and the rest of it is used to shield dark matter detectors from radiation.
That's really interesting. Hopefully the archaeologists don't mind too much that we steal a lot of their lead. Thank you very much, Elliott.
Thank you.